In a moduli space, every point represents an object or a class of objects or equivalence classes of objects or an infinite number of objects. For example, imagine you had a triangle. Imagine the sides were 3, 5, and 7. Imagine you had over here another triangle with sides 6, 10, and 14. Okay, they are clearly the same triangles up to scaling and translation, meaning if you made one or the other bigger or smaller and moved them on top of each other, you would get pretty much the same triangles. These are what mathematicians usually call equivalence classes, maybe congruent or similar triangles back in ninth grade geometry. Now, you would like to study triangles in general. What type of triangles that you can actually come up with that are not actually the same after you simply translate and scale them. So if you have triangles that can be made to look the same if you simply made one or the other bigger or smaller and moved them on top of each other, that those are considered the same point in moduli space. So let's look at the moduli space of all possible triangles. Okay, now you might notice that any triangle can be classified if you define two of its angles. The third is defined immediately after defining the first two. So in this moduli space, every point can be represented using two numbers or two parameters. Both of them are angles. So this space is then therefore two-dimensional. Two numbers are required to specify a point inside of this moduli space. You might also realize or notice that this space is bounded. The largest or smallest any angle can be is 0 and pi, 0 and 180. Every point in this space represents an infinite number of objects, but all of those objects represent the same equivalence class. So you might say that each point represents a single equivalence class. Now, this was a simple example, but you can study the structure of objects like triangles or anything else that you have by using moduli spaces bounded.